In the previous videos, we have kind of focused on the flow control. We looked at uh, how to use the if, else, and structure to actually do a branching uh, to 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 construct this kind of a branching flow control. And then we looked at how to use the for and structure to do this kind of loops, right? Um, so 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 we're going to talk about flow control, a more complicated flow control, and more examples of flow control in later videos. But for now, let's switch our focus to talk about some of the basic data structures provided by Matlab. So Matlab was originally called Matrix Laboratory. So Matlab is just a kind of abbreviation for the so-called Matrix Laboratory. So one of the fundamental data structure provided by Matlab is actually matrix. So matrix, uh, so Matlab, one core functionality of Matlab is actually linear algebra. It's basically operations on matrices, basically. So so if you actually treat a matrix as some kind of a uh, a data object, then you can build lots of different kinds of operations on it. And in mathematics, those operations turns out to be an algebra, and you can actually use those algebra to solve many different kinds of realistic problems. So now let's the first thing we're gonna do is to actually try to see how we can actually construct matrices, and then how we can actually access the data that's stored inside of matrices. And the Matlab actually provides a very convenient approaches for us to do that. And then the second thing we're going to sort of look at are those operations that we can apply on matrices, right? And one of the fundamental operations is basically matrix multiplication, right? So what we're going to do is to try to actually implement our own matrix multiplication function, and then we're going to sort of compare it with the function provided by Matlab, right? And see if there's a kind of a performance difference or something, right? So again, we're gonna use the examples to motivate and illustrate how we can actually do this. So the example that we're gonna start with is this kind of example. It's this kind of example, right? So so suppose you have a pie store, right? That's gonna sell different kinds of pies. So you have beef pie, chicken pie, and a vegetable pie. And then the numbers sort of shown here are the quantities of each different types of pies that you have sold on Monday, Tuesday, Wednesday, and Thursday. So on Monday you sold 13 beef pies, 8 chicken pies, and 6 vegetable pies. And then on Tuesday you sold 9 beef pies, 7 chicken pies, and 4 vegetable pies, right? And then each pie actually costs different amount of money. So one beef pie costs $3 each, and then one chicken pie costs $4 each, and then one vegetable pie costs $2 each. And what you are trying to actually compute is actually the total amount of money that you have obtained by selling those 3 different kinds of pies on each day. Right. So if we look at the kind of mathematical operation, on Monday you sold 13 beef pies, right? So each beef pie costs $3 each. So 13 multiplies 3, right? That's the total amount of money you made by selling 13 beef pies on Monday, right? And then you sold 8 chicken pies on Monday, right? And then it's $4 each. So that's 4 times 8. And then 6 vegetable pies. That's $2 each, right? So it's 2 times 6, and then you add those add those amount of money, add the dollar amount together, you get the total amount of money that you have sort of earned on Monday, right? And that's exactly what we are trying to do here. So it's 3 times 13, 3 times 13 plus 4 times 8 plus 2 times 6, right? And then if you add them up, it's $83. So you made $83 on Monday, right? And then you do the same thing for Tuesday, and then you do the same thing for Wednesday and Thursday. So you're gonna find that on Monday you made $83, on Tuesday you made $63, and then on Wednesday you made $37, and then on Thursday you made $75. Right? And the nice thing about linear algebra, or the nice thing about matrix operations, is that this kind of calculation that we just did can be performed very efficiently if you sort of organize those data. If you try to put those data in a kind of in this kind of matrix vector format, right? So that's the quantity. So this table basically tells you the quantity of the 3 different kinds of pies that you sold on every day, on each of the day, Monday to Thursday, right? So you basically actually are organizing all those numbers into this kind of a table, right? So it's 1386, 1386. That's one column, right? And then 974, 974. That's the second column, right? And then 740, 1563. So you basically just copy all those numbers into this particular matrix, right? And then for each of the different pie, you have different kind of dollar amount, different price, right? So how do you actually organize it, right? So beef pie costs $3 each. So you have a vector with the number 3. That's sort of the first element, right? And then the chicken pie is $4 each, right? So the next number in the vector is 4. And then vegetable pie costs $2 each. So the last number in the vector is 2. Right? So if you actually pay attention to the ordering of the 3 prices, it's a beef, chicken, vegetable, right? It's beef, chicken, vegetable. Right? And then if you look at the organization of the different rows inside of the matrix, from top to bottom, it's again beef. The first row is all the quantities for beef, right? And then the second row is again is all for the quantities of chicken on different days. And then the last row is for vegetables on different days, right? So if you sort of discover this kind of pattern, then it's going to be easier for us to actually explain what's actually happening. So here the 3 elements are organized as beef, chicken, and vegetable. And then inside of this 2-dimensional matrix, the different rows are organized as beef, chicken, vegetable, right? It's the exactly same kind of ordering, right? So suppose you want to sort of switch the 2 rows. You want to put the chicken on top and beef as the second, right? So the first row is going to become A7, 4, 6, and then the second row becomes 13, 9, 7, 15, right? If you switch the ordering of the beef and the chicken, then all you have to do is to actually also switch the first 2 elements, so the first 2 prices, basically, right? You move $4 as the first element, and then $3 as the second element. Then it becomes a chicken, the price for chicken, beef, and then vegetable, right? And then it's still is going to match the ordering of the rows, right? Chicken, beef, and vegetable. So if you actually make sure that the ordering is kind of consistent for these 2, for this vector, between this vector and this matrix, and the rows of the matrix, I mean, right? Then you can do this kind of a matrix vector multiplication with some kind of a pattern, right? So now let's still use beef, chicken, and vegetable. So beef, chicken, and vegetable, right? Beef, chicken, and vegetable, right? And then all we have to do is in order to actually get the total amount of money you make for every day, all you have to do is to actually do this kind of multiplication, right? So 3 multiply 13, 4 plus 4 multiply 8, and then plus 2 multiply 6, right? So as long as you make sure that the ordering is consistent. If you do this kind of a multiplication and then summation, then you're gonna get the right price, the right amount of money. Right? So it's 3 multiply 13 plus 4 multiply 8 plus 2 multiply 6. Right? So for Monday, that's the total amount of money you're gonna get. So this kind of multiplication, this kind of component-wise multiplication, and then summation can give you the right amount of money. Right? And then you do the same thing for Tuesday, for the second column. Basically, you multiply 3 with 9, 4 with 7, and then 2 with 4, and then sum the result up. You're gonna get $63. So if you apply the same kind of a component-wise multiplication and summation between this row vector and each of the different column vectors in the matrix, you're gonna get the right amount of money. Right? So now let's try to think about how we can actually implement this in Matlab. Right? It's not exactly trivial if you are not sort of particularly familiar with this kind of matrix operations. Right? So let me sort of put the two windows right next to each other. New script. Let's write a script first. Let's write a script, and then matrix multiplications. Right? And let's save it. Let's just call it matrix multiplications. Right? Matrix multiplications. So the first thing is that we need to get those numbers into Matlab. Right? So how do we actually construct a matrix in Matlab? The simplest way is just by typing those numbers. Into the matrix. So basically in Matlab, the basic way for constructing a matrix is to use the square brackets. So suppose let's call this particular matrix, let's call it quantities. Right? So quantities is going to be a matrix, and it's going to be a 3-row 4-column matrix. Right? So to put those numbers into a matrix, we can use this square brackets. You can use the square bracket, a pair of square bracket, and then inside of this pair of square bracket, what we can do is to actually specify the rows. Right? We have like 3 different rows. So the first row is going to be 13, right? And then we use a comma to separate the different numbers in the same row. 9, and then 7, and then 15, right? That's the first row, right? 13, 9, 7, 15. 13, 9, 7, 15, right? And then we need to switch to the second row, right? So how do you actually separate different rows in the same matrix, right? You use a semicolon. So every time Matlab sees the semicolon, it's gonna sort of understand that I'm switching to a different row, right? So every time it sees a comma, it's gonna understand that it's the different columns in the same row, right? So the second row is 8, and then comma 7, comma 4, 6, and then we have one more row, right? Semicolon, and then 6, 4, 0, 3. So in principle, I should sort of put a semicolon here to suppress the screen output, right? But let's look at if I execute this particular script, what's going to happen, right? And then we're going to have a screen dump. That's quantities, right? And then we have this particular matrix, right? 13, 9, 7, 15, 8, 7, 4, 6, 6, 4, 0, 3. That's exactly as what it appears here. Right? So basically, that's how you actually construct a matrix by hand, basically. Right? Let's use the semicolon to suppress the screen output. So this semicolon is actually indispensable. You must have a semicolon to actually separate the different rows basically. But this comma is optional, right? So if you get rid of the comma and then use a space, use an empty space or white space to separate two numbers, Matlab is gonna understand that it's actually separating two columns on the same row. But if you want to sort of get rid of the comma, you have to do that for every row, right? And then if you do that, Matlab is still going to understand that it's still going to sort of give you the correct matrix, right? So you can either use a comma or use a white space to separate the different numbers on the same row, basically. Right? Either way is fine. Either way is fine. And then, if you want to separate the different rows, semicolon is the right way for doing that. But if you want to use a return key, for example, right? If you sort of separate them into like multiple rows, and then is the semicolon still sort of necessary, right? Let's find out. Let's just do that. Right? So in this case, I'm not using semicolon to separate the different rows, different numbers on the same row, and I'm not using the semicolon to separate the different rows. Right? Let's still run it. Right? So it's still gonna work. Actually, it's still gonna work. Right? So you can use a return key. So basically just press enter at the end of every line, at the end of every row. At the end of every row. So you are still going to be able to actually get the right matrix. Right? So you can separate the different numbers on the same row using either a comma or a white space. Right? And you can separate the different rows of the same matrix by either using a semicolon or a return or the enter key, right? But let's still put them back into like the same line, right? So that's our quantity matrix, right? That's our quantity matrix. Let me just double check to make sure that I got the numbers right. Yeah, and then let's use the semicolon. So that's our quantities matrix, right? That's basically this particular matrix. And then we're gonna need another vector to represent the price, right? Let's call it prices. Prices is gonna equal to so for the prices, it's just three numbers on the same row. It doesn't actually involve multiple rows. It's just a one row. So in that case, all we have to do is to construct the numbers in one row. That's 3, 4, and 2. Right? But this time, let me use comma. Right? Maybe let me run it again. 3, 4, 2. Right? So the prices is 3, 4, 2. Right? And then we can compute the revenue, right? So the total amount of money that you actually obtained for each day, right? Let's call it revenue, right? Let's call it revenue. And what we have to do is to compute the revenue for 4 different days, right? For 4 different days. Let's just do the revenue for Monday first, right? Let's call it revenue. Revenue Monday, or MON, right? So what's going to be the revenue for Monday? What's going to be the expression for computing the revenue for Monday, right? Suppose we just want to type up those numbers, then it's kind of easy, right? 3 times 13 plus 4 times 8 plus 2 times 6, right? And then that's going to be our revenue for Monday. If we just compute that, our revenue for Monday, that's exactly 83, right? But suppose we don't want to use those numbers anymore. Right? We don't want to use those numbers. Instead, we want to use the right number, right element inside of these two matrices, inside of the quantity matrix and then the price matrix, price vector. We want to use those things to the elements inside of those two matrices to do the same calculation. How can we actually do that, right? So 3 is what? 3 is the first element of prices, right? So how do we actually how do we actually retrieve the first element inside of this particular matrix, right? It's actually a vector, right? It's because it's just it has only one row, right? So how do we actually retrieve the first element of this vector? And Matlab actually provides a very simple syntax, which is actually just like a function call. Prices 1, right? So if you type up prices 1 with parentheses, not square bracket anymore. So when you construct the matrix on the right hand side, you use square bracket, right? But here you're actually retrieving the first element inside of the prices vector. So you have to sort of use parentheses, just like doing a function call with the correct input, right? And the input we want is the first element, right? So it's 1 here, right? So for one-dimensional vector, that's kind of enough for us to actually retrieve the right price, right? So if you just copy and paste this code into the command window, then it's gonna return 3. Right? That's exactly this number here. That's exactly this price here. Right? And then the quantity that we want to multiply with is 13. Right? So how do we actually retrieve the quantity 13 from this quantities matrix, right? So prices is just a one-dimensional vector, but the quantity is actually a two-dimensional matrix. And this number 13 actually locates on the first row of the first column, right? So we need actually 2 indexes in order to actually get to this particular 13. And the indexes are basically just the row ID and the column ID. So how do we actually replace 13? We can call it quantities. Again, parentheses, but now we need 2 numbers. One is the row index, which is the first row, right? And then comma, the second index, the column index, which is also 1, right? And sometimes we want to sort of put a space here. Sometimes we don't want it. It depends upon your preference, right? It doesn't really matter too much. Let's put a space here. Right? That's the first row and the first column. And then let's try to replace the second thing in the expression with the right elements, right? So 4 is prices 2 now, right? That's the second element in the prices vector. And then 8 is what? 8 is here. That's the first. That's the second row of the first column, right? That's the second row of the first column. So that's gonna be quantities. Second row, first column, right? And then let's replace the last part of the expression, right? So 2 is what? 2 is prices. The third element in the prices, and then 6 is the third row, first column, right? Quantities. Third row, first column, right? So if we run this particular expression, it's still gonna give us 83 as the output, right? So revenue is still 83, right? That's the correct amount. So now let's look at this particular expression. What can we actually say about this particular expression, right? It's kind of long. It's kind of quite long, right? But can we actually detect some kind of pattern? Can we detect some kind of pattern out of this particular expression, right? So the first thing we're going to notice is that the second index goes into the quantities matrix is always 1, right? The second index doesn't change, right? It's always 1. Right? But the first index that goes into the quantity, which is basically the row index, goes from 1 to 2 to 3. See? And then the index that goes into the prices vector also changes from 1 to 2 to 3. Right? Do you see the pattern? So it means what? It means that we can actually replace this very long expression by using a for loop. Right? So if you don't believe me, let's give it a try. Let's give it a try. All right, let's give it a try. So let me comment out this line, and then let's write a for loop to replace this very long expression, right? So for, I'm gonna use a iterator that's called IC. That means column index, right? Index of column, right? So 1 to 3, right? So last time when we did the for loops, we looked at this range operator, right? So the range operator allows us to actually generate a sequence of numbers, right? With this number with 1 as a starting number and then 3 as the ending number. So 1 colon 3 just means 1, 2, 3, 3 numbers, right? And then what we are gonna do, right? What are you gonna do? So we're gonna use this IC to index into prices, and also as the column ID to index into the quantity. Is that column ID or it's a row ID? Sorry, it's a row ID, right? So let's call it IR, right? So IR, it's the row ID that actually changes from 1 to 3, right? The column ID is like fixed to 1, right? So what we can do is to do this thing: prices IR multiply quantities IR 1, right? So these three expressions, all these three expressions are kind of summarized in this line of code, right? So as IR goes from 1 to 3, it's gonna loop through these three expressions, basically. These three expressions, right? When IR equals to 1, then its price is 1 times quantity is 1, 1. When IR equals to 2, then its price is 2 times quantity is 2, 1. Right? And then when IR equals to 3, then its price is 3 times quantity is 3, 1. Right? So by doing this kind of for loop, we actually have constructed these three expressions. Right? But don't forget, it's not the three multiplications that we want. We want a summation. We want this kind of addition for these three multiplications, right? So how do we actually add those three products together, right? So let's initialize revenue month to 0 first, right? So outside of the loop, before we actually enter the loop, revenue Monday is set to 0. So it has the initial value of 0, right? And then all we have to do inside of the loop is to actually do this thing. And that's all we have to do, right? So in terms of mathematics, this kind of an equal sign doesn't really make sense, right? How come revenue Monday equals to revenue Monday plus this additional number, right? But in terms of the programming language, it actually means assignment, right? So the revenue Monday is gonna start with 0, right? So it's for the first iteration when IR equals to 1. That's the first iteration. So revenue Monday is gonna be 0, right? So 0 plus price is 1 times quantity is 1, 1, right? So it's 0 plus anything is the result is exactly this thing, right? It's the price is 1 plus times quantity is 1, 1, right? You add to 0, right? and then you assign the result of the addition back to Revenue Monday, right? So by the end of the first iteration, Revenue Monday is gonna have the number which is price is 1 plus multiply quantity is 1, right? And then you go back to the beginning of the loop, so IR becomes 2, right? So in the second loop, IR becomes 2, and then you reevaluate this the left hand side, right? So now Revenue Monday is no longer 0 anymore. Revenue Monday actually has the value which is price is 1 times quantity is 1, right? Which is obtained from the first iteration. And then at this stage, you add prices 2 times quantities 2, right? That's this part of the expression, right? So by the end of the second iteration, what's actually being assigned to Revenue Monday is going to be prices 1 times quantities 1 plus prices 2 times quantities 2, right? And then you go to the third equation, IR becomes 3, right? And then you do this multiplication, price is 3 times quantity is 3, and then you add it to the Revenue Monday of the previous iteration, and then you add them together and then assign the result back to Revenue Monday. So by the end of the third iteration, Revenue Monday should have the correct value. Let's just print it out, right? So I'm just so instead of just using the disp function, I'm just gonna sort of echo this thing in the command window, and you can see 83, right? It's still 83. So that's correct. That's still the correct result, right? So that's just for the first the revenue that's on Monday, right? But don't forget, we have to sort of compute the revenue for 4 different days, right? So it's not just for Monday. We also have to compute it for Tuesday, Wednesday, and Thursday, right? Which means what? We have to apply the same kind of a multiplication and summation process between this priced vector and the second column of the quantities matrix, right? So here we're basically just using the first column of the quantities matrix. So inside of this loop, IR goes through the different rows of the first column, right? But don't forget, this quantities matrix has 4 different columns, right? It's got like 4 different columns. So here we only used like the first column. So you can imagine what's gonna be the revenue for Tuesday, right? Let's just change this code from Monday to TUE. Right. Then all you have to do is to change this column index from 1 to 2, right? And then if you actually display Tuesday, then it's gonna be 63, right? And then if you want to know what's actually the revenue for Wednesday, all you have to do is to actually change revenue Tuesday to Wednesday, and then change the column index to 3. Then that's 37, right? And if it's a Thursday, all you have to do is to THU, THU. And then you change it to the 4th column. Right. Then that's 75, right? So basically, I was actually changing this source code, right? For every day of the week, I basically just changed the name of the revenue, and then another thing that I changed was basically just the column index that goes into the that goes into the quantities matrix, right? So how do we actually automate this kind of process, right? Instead of I have to sort of change the name and the kind of column index every time, how can we actually automate this kind of process so that I don't have to sort of do this kind of manual change to the source code, right? How do you actually do that? How do you actually do that, right? So you can sort of see that every time I make a change to the quantities, I just increased the column ID by like a 1, right? I just increased the column ID by 1, right? So is there any way for me to actually iterate through, this column ID automatically, so that the column ID that goes into the quantities matrix automatically ranges from like 1 to 4, right? Can we actually do that? And it's actually quite easy to do. And the correct way for doing that is just by wrapping this particular for loop inside another for loop. Let's call it for IC. Goes from 1 to 4. And then all we have to do is to index it, indent it into like this kind of way, right? And then all I have to do is to actually change this 4 to IC, right? So as the IC goes from 1 to 4, this inner loop, this inner for construct is going to be executed for like 4 different times, right? And every time this particular inner loop is executed, the IC is going to change from 1 to 4, right? So for the first iteration of the IC equals to 1, right? And this for loop, this inner for loop, are going to be executed with the IC fixed at 1. And then IR still goes from 1 to 3, right? And then for the second IC loop, IC is going to have a value of 2, right? And then this inner for loop are going to be executed with IC fixed at 2. And then IR still loops through 1 to 3, right? So by doing this, by wrapping this for loop inside of this for loop, we were able to actually iterate through all the different column numbers also, right? And it's automatic. We are not really changing anything. We are not really sort of manually changing the source code, right? And then there's a second problem. Right? We solved this problem, right? Which is just instead of manually changing this kind of a column index every time, all we have to do is to wrap the whole for loop inside of another for loop, right? This part is kind of easy to fix. But what about the manual change of the variable name? What about the manual change of this variable name, right? Can we actually replace the manual change of the variable name with some kind of automatic code, right? Can we actually do that, right? So don't forget, we're actually computing revenues for 4 different days, right? It's not just for 1 day, right? We're computing the revenue for 4 different days. So if it's 4 different days, then it's actually 4 numbers, right? If you look at the expression here, the result is supposed to be actually 4 numbers inside of a square bracket, right? So that's also another vector, right? It's a row vector with 4 different elements inside of it, right? And the first element is the revenue for Monday. The second element is the revenue for Tuesday, that kind of thing. So what we can do is actually, instead of changing the variable name every time for a different day, let's try to construct another matrix. Let's just call it revenues, right? Instead of the revenue for 1 day, let's construct a vector that's called revenues, and it's gonna have like 4 different elements in it, right? And then every element is gonna be the revenue for 1 particular day, right? And then we want to initialize the revenue for every day to 0. And Matlab actually provides a quite convenient function that's called zeros. Right? This zeros function is going to take a matrix as input. And this matrix is supposed to have two elements, which is just specifying the dimension of the matrix on each of the direction. So the first number inside of this square bracket is supposed to be the row number, right? So here the row number is just one row, right? But it's gonna have 4 columns, right? So it's one row. It's one row, and then 4 columns, right? And that's sort of the input to the zeros function. Right? So if you actually execute this line of code, maybe if I just type zeros, 1 row 4 column inside of the command window, you're gonna see that Matlab is gonna produce a matrix with 1 row and 4 columns, and all filled up with zeros, right? And that's exactly what we want. Right? So the first element of revenues vector is gonna be the revenue for Monday, right? And then the second element in the revenues vector is gonna be the revenues for Tuesday, right? And then the third element is going to be the revenue for Wednesday, and then the fourth element is going to be the revenue for Thursday, right? So now we have actually constructed this revenues vector. But how do we actually use this revenues vector inside of this double loop, right? Inside of this kind of a nested loop, right? So let me show you the syntax, right? So it's not revenues. It's not revenue Thursday anymore. It's revenues. Right? Right. So for Monday, Monday is when IC actually equals to 1, right? And then Tuesday is for IC actually equals to 2, right? So for Monday, what we want to actually compute is actually the first element inside of the revenues, right? And then for Tuesday, we want to compute the second element inside of the revenues vector, right? And then for Wednesday, it's the third element inside of the revenues vector, right? So how is the actually the number the day number is actually indexed, right? The day number is actually encapsulated in this IC iterator, right? This counter, right? So for Monday, it's IC actually equals to 1, and then for Tuesday, IC actually equals to 2, and then for Wednesday, IC equals to 3, and then for Thursday, IC equals to 4, right? So if we want to compute the revenues for a particular day, then all we have to do is to actually use IC to index into the revenues vector, right? So all we have to do is to put IC here, and then IC here, right? So you can think of revenues 1, when IC equals to 1, as revenue Monday, and then revenues 2 as revenue Tuesday, right? And then revenues 3 as revenue Wednesday, and then revenues 4 as revenues Thursday, right? So once we have made these changes, if we actually run this code again, you're gonna see the 4 numbers are computed at the same time, right? That's 83, 63, 37, and 74, 75. So by using this kind of double loop, we were able to actually compute this quite complicated operation in just one very short script, right? And that's how you can actually do matrix vector multiplications, basically, right? And Matlab actually provides you with a very simple function for doing that, right? Which is just the multiplication, right? So we have seen how to actually use the star to represent multiplications, right? But for now, every time we use the star is actually between 2 numbers, two scalars basically, right? We haven't actually seen applying this star between two matrices or between a vector and a matrix, right? We haven't seen that yet. But now let's take a look. Right? So what I'm gonna do is that I'm just gonna so we've got a prices vector, right? But prices is a vector, right? It's prices. If you just use prices like an independent thing without the parentheses following it, right? Then it's gonna be used at then it's gonna represent a vector instead of just a specific element inside of it, right? Here you are using a parenthesis after the prices, the name prices, right? So that's gonna be indexing into this particular vector. You are retrieving one element from that particular vector, right? But here let's just use prices as one thing, the entire container, and then we're gonna do the multiply, right? And then quantities, right? You see, so there's no parentheses following any of those vectors or matrices. So we are not really retrieving elements from those two names, right? We are not retrieving an element from the prices vector. We are not really retrieving a element from this quantities matrix. So basically we are using the prices as a whole thing, and then the quantities as a whole thing, right? So this is a vector. It's not a number, but here it's a number, right? This is just a scalar, right? This is again a scalar, right? But here it's prices without the parentheses, that's a vector, and then quantities without the parentheses, that's a matrix, right? If we just apply this multiplication or star operator between this vector and this matrix, then what we are gonna get is exactly the thing that we just computed using this double loop, using this kind of nested loop, right? Exactly the same thing, exactly the same number, right? So maybe it's a good idea to actually do a comparison, right? So prices times quantities, and then if we just run it, right? And then this ANS is actually coming from this particular multiplication. So Matlab actually knows if you just apply this operator between two matrices, a vector is basically just a matrix with just one row, right? If you apply this star, this multiplication between two matrices, Matlab actually knows that it's not a scalar multiplication. It's actually a matrix multiplication. So internally, Matlab is going to replace this star with this kind of a nested for loop, right? But it's kind of implemented in a much more efficient way, actually, right? But in principle, this star is going to be replaced with this double loop, with this nested loop internally, right? And Matlab actually knows how to actually do this kind of a replacement automatically, just based upon looking at the structure of the two matrices. It actually knows how to do that, right? Let's stop our discussion here, and then next time we're going to look at, in the next video, we're going to look at how to actually make this operation slightly more complicated, right? Slightly more complicated. Suppose we have not just one vector, but another matrix with multiple rows, right? This vector is just one row, right? Suppose we have multiple rows, right? How do we actually do the same kind of calculation, right? You can imagine what's gonna happen, right? What's gonna happen if you have just one row, then you do this kind of a nested loop, right? Now suppose you have like multiple rows, right? Suppose you have like a 5 rows or something, right? Then all you have to do is to actually apply the same kind of operation, to apply this nested for loop like 5 times, right? And every time you just use a different row, right? And you can imagine what's gonna happen, right? What's gonna happen? All you have to do is to actually wrap. All you have to do is to actually wrap this nested loop inside of another for loop that goes from like a 1 to 5, that kind of thing, right? And you can imagine how to actually implement that kind of a nested loop, a triple nested for loop, to actually implement a matrix multiplication.